and welcome back. So now we're going to hopefully be finishing up our study of angles formed by parallel lines and proving lines parallel. And we're going to, in this problem, we're going to use the properties of parallel lines to find the value of x and tell which theorem you used. You always need to justify your responses, right? And the very first thing you should note is what kind of angles we have. Right? So we have, notice they're on the outside of the parallel lines. We know they're parallel because they're marked parallel. Opposite sides of the transversal. Right? So angle A and angle B are alternate. That's not an N. Alternate exterior angles formed by parallel lines. Oops. And so that means they are congruent to one another. Right, so we have two different kinds of relationships. We have angles formed by parallel lines, congruent and supplementary. Where our alternate exterior angles, they are congruent. So we're going to set x minus 8 equal to 55. And now all we have to do is solve for x by adding 8 to both sides. And so x is equal to 63. And there we go. All there is to this problem. All right, let's go. Let's solve another problem. All right, so here we have two sets of parallel lines intersected by two sets of transversals, and they're both parallel as well. All right, so if the measure of angle 4 is 116 degrees, let's write that in. We want to find the measure of angle 9. Right, so they don't really have a direct relationship. So sometimes you need to find the measures of other angles to find the measure of the angle you're looking for. So let's start with angle 10. So angle 4 and angle 10 are, what kind of angles are angle 4 and angle 10? Right, notice they are on between those parallel lines. They're in between, I guess it's good enough, between N and P, opposite sides of line K. So those are alternate interior angles. And we know, of course, and they're formed by parallel lines. And of course, alternate interior angles formed by parallel lines are going to be congruent. So that means that angle 10 is also 116 degrees. Right, now how about angle 10 and angle 9? They have a relationship. Right? If you notice, they're right next to one another. Right? They're formed by intersecting lines. They're adjacent. They are a linear pair. And it doesn't matter what kind of lines we have with linear pair angles. They are always supplementary, all the time. Right? Doesn't matter what kind of lines we have. That's why linear pair angles can't be used to prove lines parallel, because they're always supplementary. All right, so that means that angle 9 plus angle 10 add up to 180 degrees. And we already know angle 10 is 116. And if we subtract 116 from both sides, angle 9 has to be equal to 64 degrees. And there we go. We have found the measure of angle 9, right, by using relationships. And we had to use two relationships, right? Because angle 4 and angle 9 really don't have a direct relationship that we can justify, but 4 and 10 do, and 10 and 9 do. All right, so sometimes we'll just find the measures of other angles. That's easy enough, right? All right, so if angle 15 is 57 degrees, find the measure of angle 2. All right, so here they're not even on the same set of lines. All right, so we're going to have to work our way across. All right, so let's use angle 15 and angle 8. All right, so here's angle 8. What kind of angles are those? All right, those are in between angles and, lines N and P. Right, between those parallel lines, those are consecutive interior angles. And of course, they're formed by parallel lines. I'll give myself a little bit more space because I need to write down the relationship. Now, consecutive interior angles, they're supplementary. All right, so let's find the measure of angle 8. I'm going to move this down a little bit. All right, so that means that angle 8 plus angle 15 add up to 180 degrees. We know that angle 15 is 57 degrees. And if we subtract 57 from both sides, angle 8 is going to be equal to 123 degrees. All right, so now we want to find the measure of angle 2 because angle 8 and angle 2 have a relationship. All right, let's look where angle 2 is. All right, they are alternate exterior angles formed by parallel lines. So of course they are congruent. And that means if angle 8 is 123 degrees, so is angle 2. That has to be 123 degrees as well. And there we go. We have solved another problem. All right, so we want to find the value of x so that line J is parallel to line K. So here we have the U.S. Navy Blue Angels shown in the picture. That's an actual photograph. It's blown up quite a bit, so maybe a little pixelated. And they do have to fly in a certain formation, right? So that planes are parallel to one another, right? Because they're flying very, very close. They're flying very, very fast. And if they didn't maintain that formation, that parallel line formation, well, they might run into one another, and that would be very, very bad. So we want to identify the relationship between the angles given, right? So here we see we have angles that are between the parallel lines, and they are on the same side of the transversal. So they are same side interior angles. That's also known as consecutive interior angles. Right? Two names for the same thing. Right, so once you know the type of angles you're dealing with, you want to identify the relationship. Are they congruent or are they supplementary? Right, determine if congruent or supplementary to guarantee the lines parallel. Well, to guarantee our lines are parallel, our consecutive interior angles, of course, have to be supplementary. So now we can set up our equation and solve. And if our angles have to be supplementary, that means they have to add to 180 degrees. So that means that 5x plus 115 equals 180 degrees. If we subtract 115 from both sides, we have 5x is equal to 65, and then divide by 5, x is equal to 13. And there we go. We have solved for x. Right? And we've found the value of x that guarantees that line J has to be parallel to line K, and that will keep our Navy Blue Angels safe. All right, so let's think about this one. Does the diagram give us enough information to conclude that line C is parallel to line D? right? So if you're solving a problem like this, always identify the type of angles you're given. Right? So we're given outside our lines there. Right? We don't know they're parallel because we're trying to prove this. Outside the lines, opposite sides of that transversal, those are alternate exterior angles. Now, is that enough information? Right? Well, we know that our lines are parallel when the alternate exterior angles are congruent. So therefore, we know that line C has to be parallel to line D, because that's only going to be true, right, when our alternate exterior angles are congruent. So if we know they're congruent, our lines have to be parallel. If the lines are parallel, alternate exterior angles have to be congruent. So that is enough information, right? So if you know one of your 4 postulates is true, your alternate exterior angles are congruent, your alternate interior angles are congruent, your corresponding angles are congruent, or the consecutive interior angles are supplementary. That will be enough to prove your lines are parallel. So we have 4 techniques. All right, so which statement, so here now we have a multiple choice question, what statement would always make lines K and M parallel? Let's go through these. Right? I included this in the lesson rather than making this a question for you because I wanted to discuss it. All right, so, and let's go through each one of them and determine, is that enough? Yes or no? And if it's not, why not? Angle 2 is congruent to angle 4. So let's mark that. Is that enough to prove our lines are parallel? Well, let's think. Are those alternate interior angles, alternate exterior angles, consecutive interior angles, or corresponding angles? Well, no, they're not. Those are vertical angles. And we know vertical angles are always congruent. So this is a no. Vertical angles are always congruent. Always congruent, right? So that doesn't mean our lines are parallel, right? That'll be true all the time. Always true. Right? So let's try the next one. Angle 5 plus angle 6 equals 180 degrees. Right? So this one plus, I guess I won't use arcs here. I'll just circle. Angle 5 plus angle 6 add up to 180 degrees. Is that enough? Well, let's identify what kind of angles are those. All right, so those are adjacent angles formed by intersecting lines. They are linear pair angles. And linear pair angles, they're supplementary all the time. Now, if you have any trouble with these, another way you could think about it are, and it's not a justification, right? You can't say this is a justification, but it's a way to think about it, to remind yourself. Notice that 2 and 4, they're only on one line, right? They're only on one of our lines that we're trying to see if they're parallel. Only on line K, right? Notice those two, neither of those angles are formed by line M. And the same thing with our linear pair angles. They're only formed by line M, not line K. Right? So if they're only formed by one of the angles, they're not going to be enough to be able to prove your lines parallel. Now that's not really a justification, right? The fact that vertical angles are always congruent, linear pair angles are always supplementary, that's our justification. But that's just a way you could think about it. All right, so now let's see about this one. Angle 3, the measure of angle 3 is equal to the measure of angle 5. Let's mark our angles here. And let's think, what kind of angles are these? Well, those are alternate interior angles. And we know that alternate interior angles, they're only congruent if the lines are parallel. So if our alternate interior angles are congruent, our lines must be parallel. Right? So that is our answer. Let's just check the other one. Right? So the measure of angle 1 plus the measure of angle 5 equals 90 degrees. Well, that doesn't really prove anything. Let's look what kind of angles these are. Just kind of right over it. Those are corresponding angles. And we know that corresponding angles have to be congruent to prove lines parallel. Adding to 90 just means you're complementary. So adding to 180 is supplementary, adding to 90 degrees is complementary, and that does not prove our lines are parallel, because we would have to know we're congruent, because those are corresponding angles. But if your alternate interior angles are congruent, your lines have to be parallel. So if you have a multiple choice question like this on a formative or a benchmark, right, go through your choices. Right? You're looking for one of your 4 relationships to prove lines parallel. Right? And vertical angles and linear pair are not enough to prove lines parallel. You have to have congruent alternate interior angles, congruent corresponding angles, congruent alternate exterior angles, or supplementary consecutive interior angles, or same side interior angles. Right? So here's how to solve a problem like this and all of our justifications. Right? Let's look at a little bit, a few more problems. We're going to prove lines parallel. Right? The very last part of this lesson is all proofs. So given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. All right, so here we have 2 sets of lines to look at. 8 and 11. Always a good idea to circle your angle so you can see what you've got there. So we want to determine which lines, if any, are parallel. So we have angles 8 and angle 11. Right, so the only way to determine our lines would be parallel, because it doesn't say anything. So it doesn't really say anything, it just says and. If angle 8 plus angle 11 equals 180 degrees, the lines that would be parallel are the lines that those 2 angles are in between. Then line A would be parallel to line B. The postulate or theorem we're using is the consecutive, and technically, because we're going the other way, we're proving the lines parallel rather than knowing which angles are congruent given the lines are parallel. Technically, this is the converse of the consecutive, I'm going to abbreviate, interior angles postulate, but we have no more space. Leaving the word postulate off is not really a big deal. All right, angles 12 and angle 14, let's circle them. All right, angle 12 is right here, and angle 14 is right here. All right, so if angle 12 was congruent to angle 14, then the lines that they're on opposite sides, or on the outsides of, which is these 2, then C would have to be parallel to D. Line C would have to be parallel to line D. And the theorem we're using is the converse, because we're working backwards, of the alternate exterior angle postulate. All right, I'm going to do 2 more. And I probably have to erase something because now it's getting a little crowded in there. So let's erase. All right, angle 10 and angle 2. All right, so what kind of angles are those? All right, they're on the same side of our transversal, right? This, I don't want to, line C there. And they're in the same position on lines A and B. So if angle 2, or angle 10, I'll write that one first, is congruent to angle 2, then okay, the lines that they're above, then line A would have to be parallel to line B. Postulate we're using is the converse. Those are corresponding angles of the corresponding angles. Postulate. And actually I can get postulate in here. I'm hoping my voice sounds okay. My ears keep popping on and off. It's a relief when they stop being popped and all blocked, and then it lasts for like 5 seconds. It's like being in a tunnel. 5 and 3. So here they are. All right, notice they are between these two lines, opposite sides of line A. So if angle 5 is congruent to angle 3, then the lines that they're in between, line C, would have to be parallel to line D. The postulate that we're using, those are alternate interior angles. So we would be using the converse of the alternate interior angles postulate. And alternate interior angles is as much as I'm getting up there. All right, and another set of problems done. We're just zooming along. Proven lines parallel, left and right. All right, so this is what's called a paragraph proof. All right, this is like kind of a sort of an informal proof. It's not exactly a proof. This one is but it's kind of is a proof. Actually, it's kind of like this. If I made it sentences, it'd be a paragraph proof. And so paragraph proof, you're just writing in sentences to prove whatever it is you're asked to prove. In this case, we're asked to prove that line P is parallel to line M. We're given some information to start with. We're given that line M is perpendicular to line L, and line P is also perpendicular to line L. So line L is a blank of M and P. What's the relationship of line L to line M and P? Well, notice it's intersecting those lines. And what do we call a line that intersects two or more lines? Do you remember the vocabulary word? It's a transversal, right? So line L is a transversal of lines M and P by definition. And that just means that if you have a line that intersects two other lines, that's the definition of a transversal. Angle ADC is congruent to angle BED because, so let's look at our angles there. Angle ADC right here and angle BED right here. Why are those angles congruent? Well, look. So if you say corresponding angles, you would be wrong, even though they are corresponding angles. You know why you'd be wrong? You'd either be wrong because we don't know the lines are parallel. And if we don't know the lines are parallel, we don't know the angles are congruent. But what we do know is they're both marked with a little box. And that little box means something, right? It means those are 90-degree angles, right? So and all right angles are congruent because they're all 90 degrees. So angle ADC is congruent to angle BED because all right angles are congruent. They are right angles, right? You could also have said both there because they're both right angles. They both equal 90 degrees, right? I'll put that there too. They all have the same meaning. They both equal 90 degrees, right? Either of those would be perfectly fine. Therefore, blank is parallel to blank, right? So because we know those angles are both 90 degrees, we now know that line M is parallel to line P by the converse of the corresponding angles. I'm going to abbreviate that, or write it below. There we go. All right, so now that we know they're both 90 degrees, we realize, hey, our corresponding angles are congruent. If your corresponding angles are congruent, our lines have to be parallel, because whenever our corresponding angles are congruent, our lines are always parallel, right? So if the lines are parallel, the corresponding angles are congruent. And if the corresponding angles are congruent, the lines have got to be parallel. That's the way it works. All right, so we want to complete, this is called a flow proof. So it's kind of like a flow chart, right? So and instead of putting our statements in columns, right, we kind of have them go around in a circle, sort of, and then we have to give our reader here some idea of the order, and hence the A, B, C, D, E, F, G. And for every statement we make, we have to have a reason. So it basically is like a two-column proof. It's just not written in columns. So we're going to complete the flow proof. We're given that angle 1 is a right angle. We want to prove that angle 3 is a right angle. Right? So this is nothing about parallel lines, as they're certainly not parallel lines or intersecting lines. Angle 1 and angle 3 are vertical angles. So how would I know angle 1 and angle 3 are vertical angles? I can see it in the picture, right? I've got two intersecting lines, and angle 1 and angle 3 are opposite each other in those intersecting lines. That is a given. And in this case, it is a picture given. So things like a right angle being marked. So even if they didn't tell us angle 1 is a right angle, the fact that it's marked in the picture makes that a given. And in this case, the fact that we know they're vertical angles because it is in the picture, right? We don't have to make any assumptions, like maybe that looks like they're vertical angles. No, they are vertical angles. You got two intersecting lines, and those are on opposite sides of those intersecting lines. Right? So if you have two intersecting lines, and only two intersecting lines, and they're not adjacent, they've got to be vertical. All right, so angle 1 is congruent to angle 3, and that's because vertical angles are always congruent. Angle 1 is equal to, measure of angle 1 is equal to the measure of angle 3. If you notice, we just went from congruent to equals. What's that postulate that says you can go from, or the definition that says you can go from congruent to equals or equal to congruent? Why, that's the definition of congruence. That's what congruence means, right? Congruence means you have the same measure. So if you have the same measure, you're congruent, and if you're congruent, you have the same measure. That's what the definition is, right? So we can justify that with what the definition of congruence. Angle 1 is a right angle, right? It's right there in the very first statement of that proof, next to the words given. It is a given piece of information. I had to abbreviate it so I could fit it in that little box, but it is a given. All right, moving right along. Measure of angle 1 equals 90 degrees. If it's a right angle, we know it's 90 degrees. All right angles equal 90 degrees. The measure of angle 3 equals 90 degrees. All right, so this one's a little bit trickier, only because it's not right next to one another. So you might say something like, oh, all right angles are 90 degrees. But we don't know angle 3 is a right angle. That's what we're trying to prove, right? So you can't use what you're trying to prove to justify a statement, right? That's backwards, right? You can't justify what you're trying to prove, you know. You can't, or justify you can't use so if you got something you're trying to prove, you can't justify it with the very thing you're trying to prove, is what I'm trying to say. All right? But let's look around our proof, right? And notice I see angle 3 written someplace else, over here. So let's take a look here. Angle 1 is equal to angle, I'm going to write it right here. So the measure of angle 1 equals the measure of angle 3. And the measure, I see measure of angle 1 someplace else. The measure of angle 1 equals 90 degrees. Right, so both things, measure of angle 3 and 90 degrees, are equal to angle 1. Therefore, they're equal to one another. That's the transitive property. So you have to be careful. Right, so we use other reasons and other ways to connect ideas to prove what we're trying to prove. Right? It's like we're going through a maze, right? Like a puzzle. And we're trying to go from one piece to the next, right? By connecting the information. So you can't jump too far ahead, right? So we don't know angle 3 is a right angle until we prove it, right? So we cannot use that reason. But we can recognize that both angle 3 and 90 degrees are both equal to angle 1, right? So they're congruent to one another using the transitive property. And now that we know the measure of angle 3 is 90 degrees, we now know it's a right angle because all right angles equal 90 degrees. And there we go. We finished our proof. We did it. Right? I don't know how many more pages are left. I don't think very many, and not enough to really make its own podcast. So I have 1, I don't think anyway, 2, 3, of course they're all proofs, 4, 5, 6, and you know what? That is enough to make its own podcast. So I'm going to close this right now. We're going to have a part 4 where I finish up. All right, so bye for now. See me in the very last section. Bye.